Hey everyone, so we're going to review the review sheet for the Unit 2 exam that we're having tomorrow. Please use this video to go over the problems and look over to see the questions. If you can ace this review sheet, you can ace this midterm tomorrow. The exam tomorrow. Okay, the first one says, solve the following inequality for x. And they give us negative 2x plus 7 is greater than 13. So, what we're going to do is we're going to use inverse operations to solve for this. We could subtract 7 to both sides. And after you do that, the 7's here is going to cancel out. We have negative 2x is greater than 13 minus 7 is 6. So we're going to divide negative 2 to both sides to get that x by itself. And then once we do that, we're left with, on the left side, the negative 2 and negative 2 will cancel out. So on the left, we're left with x. And on the right side, we have 6 divided by negative 2. That is negative 3. But if you guys remember, there's that special rule. We divided by a negative. If you divide or multiply by a negative, you have to flip the inequality sign. So because we divided by negative 2, it's not greater than anymore, it becomes less than. So x is less than negative 3. Using this, which of the following are solutions to that inequality? So it has to be any value that's less than negative 3. Is that 0? No. 8? No. Negative 7 is less than negative 3. Is negative 3 less than negative 3? No, it's equal, so it's not this one. So we said it's not 0, it's not 8, it's not negative 3. Is 1.5? Nope, that's a positive number. Is negative 2? Nope, that number is greater than. Negative 1.5, that's also bigger than negative 3. And then negative 8 is also less than negative 3. So only negative 7 and negative 8. What is the special rule for that we apply to inequalities for flipping the sign? And we just talked about this. When multiplying or dividing by a negative, you must flip the inequality sign. Okay, we're going to keep going. So this next question involves writing inequalities from graphs. So if we're given this graph, we have to figure out what's the inequality for it. On an exam, you might not be given all these things, but these are the things that can help us figure out what we need to just figure out what the inequality was. So if we look at this graph, I'm assuming we could zoom in a little more. If we look at this graph, what's the y-intercept? The y-intercept, if you look at this, is negative 3. That's where the line crosses the y-axis. It's negative 3. If we were talking about an actual coordinate, it is 0, negative 3. The slope. Let's find another clear point on the graph. If I look carefully, I see 1, negative 1 is another clear point. And how much do I go? I go up 2 and 1 to the right. So this is up 2. That's plus 2. And 1 to the right. That's plus 1. So the slope is 2 over 1, or we could say 2. Either way is fine. We usually like to write slope as a fraction. Sorry, guys. Is it shaded above or below? So if I look at this line, is the graph shaded above the line or below the line? We can see that it is shaded above. So it is shaded above the line. Is this line solid or dashed? If I look at the inequality line, we have a great solid line. Okay, so now I have to write the inequality. Well, if I'm looking at this, I know we have to have negative 3, we have to have 2. I can see it shaded above, so that means it's greater than or greater than or equal to. But because it's a solid line, that means it's only greater than or equal to. So we're going to write it like we were writing y equals mx plus b. And we know m is the slope. M is your slope. And b is your y-intercept. Sorry, guys. Okay. So, um, y equals, we're only going to change the slope and the y-intercepts. Oh, wait. So y, we're not using equals because we have an inequality. And we said it's greater than or equal to the slope is 2, or 2 over 1. We're going to say 2x. And then the y-intercept is negative 3. So 2x minus 3. And this right here is the inequality of the graph. Okay, guys, so moving on to the next one, writing inequalities from the context. This is where you write inequalities given like a word problem or a situation. On our first read, we're just going to read it out and um, listening for the situation of where we are. The cost of the bag of a popcorn in a vending machine is $2. The cost of the bottle of iced tea in the same machine is $1.75. Emily has $25 to spend on popcorn and the bottle of iced tea for her team, and she must buy 6 bags of iced tea. If P represents the number of bags of popcorn, which inequality represents the maximum number of bottles she can buy? So in the second read, we're going to look at any quantities. Oh, wait, first of all, we are talking about a vending machine. In the vending machine, there's popcorn, probably those microwavable kinds, and you have iced tea as well, and she has to buy popcorns and iced teas. On the second read, we're going to look at and underline any numbers or quantities and possibly what they represent as well. The cost of a bag of popcorn is $2 in a vending machine. The cost of a bottle of iced tea in the same machine is $1.75. Emily has $25 to spend on popcorns and bottles of iced tea for her team, and she must buy 6 bottles of iced tea. If P represents the number of bags of popcorn, which inequality represents the maximum number of bottles she can buy? This should say bags. Your paper should have it correctly. Um, so, uh, we know that P represents the number of bags of popcorn. So that's P is a number of bags of popcorn. And we know that popcorn cost $2. And we know that iced tea cost $1.75. And we know that there is $25 that she has to spend in total. So if you look at the inequalities, we know that popcorn is P. So we know that if they're buying one popcorn, they're paying $2. $2. If they're buying 2 popcorns, they're paying $4. So we could represent the cost of popcorn as 2p. And if I look at the inequalities, uh, this one has 1.75p, and this one also has 1.75p. But the other two, they both have 2p. So we just eliminated 2 of our options already. And then we also know that she has to buy 6 bottles of iced tea. And the iced tea is $1.75. So if the popcorn is 2p and the iced tea is $1.75, but she has to buy 6 of them. So they're going to multiply that by 6. Uh, and if you add that together, that's how much she's paying in total. So is there any one of them that looks like that? Uh, both of B and D have 2p plus 1.75. It is in a different order, so we can rewrite it. 1.75 times 6 plus 2p. Now, it also says at the end the maximum number. So if you guys remember from the chart, maximum means that she cannot go over $25. And if that makes sense, if she has $25, she can't spend more than that. So that means that the amount you pay must be less than or equal to 25. So our correct option here is option D. Moving on to the next, this is another type of solving inequalities, but this time we have some fractions involved. Um, there's a few ways we could do this, but my favorite way is to try to get rid of the fraction first. So what we could do is we're going to first rewrite it over here. 4 minus 2 over 3x is greater than x plus 9. So my favorite thing to do is to get rid of that fraction, and I don't like fractions at all. So what I could do is multiply everything in the inequality by that denominator. So I'm going to multiply everything by 3 on this side and 3 on this side. So this becomes 3 times 4, which is 12. When we do 3 times negative 2 over 3, this will cancel out right here. And I'm left with minus 2x is greater than, and on this side, we're going to distribute as well. So 3 times x, that becomes 3x. And then again, we'll do 3 times 9, and that becomes plus 27. Now I have something a little more easier to deal with. So we want to get the x's on one side and the positive values on the other. So one thing that we could do is minus 3x. By the way, guys, there are different ways to do this, so maybe you did it differently, got the same solution. So minus 3x to both sides. I will have negative 2x minus 3x. That is negative 5x. Bring down the 12. And we're going to bring down the plus 27. And then we have that inequality sign, which is greater than. We did not flip anything because we did not divide or multiply by a negative. Now we have all the x's on the left side. We want to get all the constants on the right side. So this 12 is on the left. I want to get it on the right. What we could do is subtract 12 to both sides. After we subtract 12, we have negative 5x is greater than, and 27 minus 12 will give us 15. And then we just divide negative 5 to both sides. And if you paid very close attention to what I said, we divided negative 5 to both sides, which means now this inequality sign has to flip because we divided by a negative. So x is less than negative 3. And that brings us over here to x is less than negative 3. Okay, this time we're dealing with some bigger numbers. So if you have your calculator on hand, that is completely okay. Uh, but all we're doing is solving for x algebraically, the same thing we did here. This time we just have some decimals instead of fractions. But we're going to follow that same process. So I actually like having my x's on the left side. So the first thing I'm going to do is I'm going to subtract 1.03x on this side as well as this side. So I can get all the x's on the left side. There we go. That will cancel this x out over here, but it'll bring it to this side. And we're going to do 1.06 minus 1.03, and you'll get 0.03x. And then you bring down everything else. We have less than 4,000 over here. And then we bring down the 2,200 over here. And that is a positive, so it's a plus sign. Now, we want to get all the constants, that's at 2,200, and the 4,000 to the right side. I'm going to subtract 2,200 to both sides. And we're left with 0.03x is less than 0.08 and then 1. So now we have this. What we're going to do here is you're going to divide 0.03 to both sides to get that x by itself. And you notice when you divide by a fraction, a decimal that is a very small decimal, you actually are multiplying. So if you do 1,800 divided by 0.03, the number is actually going to get so much bigger. So on the left side, we have the x. We have less than. And then if you divide it correctly, you would have gotten 60,000. The value of x is less than 60,000. Okay, guys, we're going on to graphing an inequality. So this one is just one inequality. I'm going to graph it on the axis below. If I look at this, this is actually already in slope-intercept form. Remember, y equals mx plus b. We have y is greater than 3x minus 7. And what I actually want to do is before we even graph, I actually want to label some stuff about this. If I look at it, I can see the m lines up with my 3, so my slope is 3 or 3 over 1. That's right here. My y-intercept at b is negative 7. I see a greater than sign, so that would mean greater than means to shade above. And I also notice because it's greater than, and it's not greater than or equal to, I'm going to have a dashed line. So we just planned out what our graph is going to look like, and we're going to now put it together. So we're going to start on the y-intercept. We're going to start on the y-intercept, and that is, if you start at the origin, you're going to go down to negative 7. So that's 1, 2, negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7. This here's my y-intercept. That's my first point. Now I have a slope of 3 over 1. That's my rise over my run. I'm going to go up 3 and 1 to the right. So 1, start at the point that we made and go 1, 2, 3 up, 1 to the right. 1, 2, 3 up, 1 to the right. 1, 2, 3 up, 1 to the right. And you can keep going as long as you have space. And then what you would do is you would take your ruler. Does this ruler work out for me? Let's see if this will work for me. This ruler is not adjustable, so we're going to have to wing it. What you're going to do is you are going to take your ruler, and because we said it's a dash line, we're going to make a dash line go through all the points. You're going to go through all the way from one end of the graph to the other. Add some arrows at the end. And you could also label your graph to say this here is y is greater than 3x minus 7. We are missing one thing, and that's the shading. So if it's greater than, we said we shade above the line. So we're going to shade above the line. And that is your inequality right there. Okay, last question. On the set of axes, graph the following system of inequalities. Okay, for this one, what we're going to do is I'm going to show you guys two different ways we can graph this. We just did the slope-intercept way, but if we can remember, there's another way we can graph inequalities or equations if they're in standard form, like this one is here. Actually, it doesn't even have to be in standard form, but if we remember this, if you say x is 0, you can then find what your y is. So and then you do the same thing for the other intercept. So x equals 0, we're going to plug in 0 for x, so 3 times 0 plus y is greater than or equal to 6. Well, 3 times 0 is 0, so y is greater than or equal to 6. And what we're saying here is that for the intercept, when x is 0, y is 6. So one point we're graphing is 0, comma 6. And I'll do this. We're going to make this the orange graph. We'll make this one the green graph. So 0, comma 6 is going to be 0 and 1, 2, 3, 4, 5, 6. We just graphed the y-intercept when x was 0. Now we're going to do the same thing one more time for the x-intercept. We're going to say, well, what if y is 0? What if y is 0? So we're going to say 3 3x plus, instead of y, we're going to say 0, is greater than or equal to 6. That becomes 3. Anything plus 0 is 0, so we're left with 3x is greater than or equal to 6. We're going to divide 3 to both sides. X is greater than or equal to 2. So when y is 0, x is equal to 2. So the x-intercept is 2, comma 0, which is here, 1, 2. I see that it is a greater than or equal to sign, so we're going to use a solid line. And if you're doing this method, you have to remember that we have to use a test point to see which side to shade. I notice that 0, 0 is not on my line, so my test point that I would like to use would be 0, 0. I'm going to say, well, is 0, 0 solution? I say 3 times, I plug in the 0 for x, plus 0 for y, is greater than or equal to 6. 3 times 0 is 0, plus 0 is 0. So is 0 greater than or equal to 6? This is false. So because this was my test point, that means that this side of the graph is not shaded, but we could shade the other side of the graph. Since the test point was false, that means the opposite side is shaded. Okay. Now, let's say we do the green one. Actually, let's redo this with the orange shading. Oh, okay. Now let's do the green, the second equation. And maybe you don't want to graph using the intercepts way. Maybe you want to use a slope-intercept way. What you would have to do is rewrite the equation to slope-intercept form. And this one isn't that much harder to do. All you have to do is, because we want to get y by itself, we want to move this negative 3. We'll add 3. Whoops. What just happened? We're going to add 3 to both sides. And now we're left with y is less than or equal, no, just less than 2x plus 3. Now I know my slope is 2, my y-intercept is 3, And now I can graph these. We no longer need this test point here, so we will take care. We're going to start at our y-intercept at positive 3. So 1, 2, 3. And then the slope goes 2 up and 1 to the right. 2 up and 1 to the right. 2 up and 1 to the right. And it does the same thing in the opposite direction, 2 down and 1 to the left. And you just need enough points so you could take your ruler and line them up. This here is a less than sign, so I'm going to do a dashed line. Try my best. Remember guys, use a ruler. The ruler doesn't work for me on the computer. And because we did the slope-intercept way and y is by itself, I can just shade where this is telling me. This says is less than, so we're going to shade below the line. Okay, now the last question says, state one solution and one non-solution. So, because we are in this system, that means anything in the shaded area where both the orange and the green are, those are solutions. So for example, if I say 3, 1, that is where both are shaded. So 3 comma 1 is a solution. But if I say a non-solution, that means anything that is in just the green area or just the orange area or in neither area. So if I say -4, 1 is not a solution. And there you go, guys. You can check out these methods, go over your sheets, and there's also the Delta Math, which has more practice that you can try as well. All right, guys, good luck. I'll see you guys tomorrow.